All right, hopefully this question forced you to go back and look at the definition of what it means to be a linear function when you have a table of information. So first of all, is it a function? Is each of these input values assigned to one and only one output value? And that's yes. So it certainly is a function. So is it linear? And what it means to be linear, what we introduced to you is that the average rate of change between any and all pairs of points is the same. Any and all pairs. So if you go back and look at the average rate of change definition, it's the same as the slope actually, the difference of the outputs over the difference of the inputs. So what you need to do is do the calculations here and determine for yourself, is it in fact the same for any and all pair of points, the numerical calculation for the average rate of change. So let's just do a couple. Let's just do from 2 to 8 here. That means we're going to subtract these and divide it by the subtraction of these. So let's see if we can do that in our calculator here in one shot. 3.053 subtracting 3.125. So that's the difference of the outputs for the first pair divided by the difference of the inputs. That's 8 minus 2 for the, again, for the first pair of information there, or data points. That gives me that. Hey, that looks pretty good. And that's saying a decrease of that many dollars, and that's what my statement says. So I did the calculation right. Let's do the second pair. So that was from 2 to 8. Let's do from 8 to 12. So the difference of those divided by the difference of those. I'm hitting second enter, so I can go back and manipulate. So 005 053 subtract, oops, 053. I can't hit the O. There's the O. Okay, 053, 12 minus 8 there for the inputs. So that's the difference of the outputs for the last pair and the difference of the inputs for the last pair, and that better be the same if it's going to be a linear function. And yes, it is the same, and so you can go back and do the other pair, which would be from here to here, and you'll see that's the same as well. So, does it represent a linear function? Absolutely. Yes, since the average rate of change is constant for any and all pair of points.